Hello, world. So good to have you with us today. I'm Brandy with Developer Relations at C Labs, working with Celo. Today, I got a special guest. I can't believe this. Zach. Zach, so good to see you with Chainlink. You want to do a quick little intro on yourself?
Hey everyone, thanks for that little intro. My name is Zach Ayesh. I'm a developer advocate with Chainlink Labs. So I'm here to help everyone be successful when they're developing their smart contracts.
Hey, and we need that. Smart contracts, they can kind of get boring, Zach. I don't know if you know this, but NFTs are hot. People are loving NFTs. There's so many things you can do. You have digital art, you have data. I kind of want to touch base on the data side. It looks like NFTs are kind of boring without data. Could you kind of elaborate on how Chainlink is solving this problem of static data with NFTs?
Of course, yeah. So, as you said, without connecting your NFT to the outside world, they can be static. They're just kind of static metadata laying somewhere. And but NFTs are this new primitive that exists online. And we can do all kinds of cool stuff that we can't do with traditional art. And maybe we want to make those NFTs dynamic. Either we want to have them with randomly generated traits, or we could have an NFT that has a trait that's based on the price of an asset. You could have a Tesla NFT that connects to the price of the Tesla stock, and its strength, like stat, goes up with the price. The possibilities are really limitless when you think of all the data that's in the world and all the different ways we could design NFTs around those.
So do you think that this is like a significant core value prop with Chainlink and the dynamic NFT space?
For sure. Yeah. I've been experimenting around with building NFTs that are dynamic. I'm trying to get that name caught on. Dynamic NFTs, DNFTs. I think that's really cool. Just last night was working on Dungeons and Dragons NFTs, where you can create your own in-game character in hard hat, and it has randomly generated traits. It has one trait, again, like that example I said, connected to the price of an asset outside. And I think, as you said, the NFT market's hot. It's only going to grow even more. And people are going to be looking to make their NFTs more creative. One cool place where we're actually seeing this live now is the famous basketball player LaMelo Ball. He has his own set of dynamic NFTs that update with his stats in real time as he plays basketball. So this is already becoming a thing.
That's so unreal. So it's like this is assisting towards the competition-based NFT spectrum. In a sense, you have these metrics that are being obtained during the life cycle of this NFT in a dynamic way, so that way it can facilitate competition-based metrics. Can you kind of elaborate a little bit more on that, like why that might be important for users thinking about dynamic NFTs, and also share some of the hurdles, like what are some things that developers should be thinking about as they're adopting this approach?
Yeah, no problem. Yeah, so competitive NFTs, like in the LaMelo Ball example, now the fans have a way to access those stats in real time on the NFT. They can own that card. So imagine you were a kid, and maybe if you were into collecting cards, you bought the Rookie of the Year card, and it updated in real time. Now you're like very invested in the success of that player. You kind of feel like you're progressing with them. Another cool place would be like, a lot of us are wearing these sensors on our bodies now, like Apple Watch, measures your, there you go, measures your heart rate and a lot of your health parameters. What if we could kind of incentivize people through like competitions to better their health? I find that to get myself in shape, if I make it a competition, if I say, hey, everyone, let's take our health trackers, let's measure, let's say I'm going to burn 1,500 calories, 2,000 calories every day, something crazy. And, having an NFT that represents that on chain and I can see the value go up as I do good in that competition, that's invaluable. Like, I think that'd be a really cool space to explore.
I'm excited for that. I definitely know that I would be participating more in the workout sandbox if I had gamification with real value that I can emotionally connect to. Because if today we have still static components, like you look at Peloton, they're doing a great job today with being dynamic in the way that they're providing content for users to motivate them. But it stops there once when you get off the bike. And with dynamic NFTs, you carry the life cycle forward.
Exactly. Yeah. And like, you have ownership of it. And there was another part to your question. What problems should developers look towards when they're making these NFTs? So, this is really where Chainlink comes in. If you're going to make a dynamic connected NFT, you want to make sure that the connection to the outside world is as strong as the blockchain it's on. So, if they're developing on Celo, it's decentralized, right? So there's many nodes running this software, and you don't want to rely on a single centralized source to bring that data in and break the awesome properties that the blockchain has. And so later in the presentation, we'll go into a little bit more detail on why this is a thing. But I think really being cognizant of the security of how you're bringing that data in is something all developers should take very seriously.
Well said. Well said. I'm excited because today you have a presentation. You're going to be going over a little bit about like the building blocks of layering technologies, utilizing oracleized data. So I'm super excited. I would like to share, like, here with Celo, we have a platform that is there for you. We have a hackathon that's going on now. So if you have an NFT idea, maybe you're thinking about dynamic NFT, you should be joining our hackathon. Go to defiforthepeople.org, join the hackathon. It's active now, defiforthepeople.org. Join it and start building on your idea because good things are coming. Our platform is growing and we have fantastic partners in this space. Chainlink is one of them. I cannot share any further details on that at this very moment, other than the excitement of how cool this is to have Zach here. And I want to hand it off to you, Zach. You got a presentation. Maybe you can share some building block love of layering this tech with the audience. We do have a question about templates, frameworks, dynamic NFTs that you know about. Let's save those questions for the end. You'll do a presentation. We'll go ahead and do Q&A with the community afterwards. Sound good?
Sounds great. And very motivating speech.
Kick it off. I'm going to go ahead and mute myself and turn off my video. I'll wait until after the presentation and join back in.
Cool. And I am sharing my screen.
All right.
All right. Let's go ahead and jump on in then. The very motivating speech. So let's find out how we can empower all you devs building on Celo to build the strongest, most secure, and highest quality connected smart contracts available. So I'm going to make this presentation a little introduction to Chainlink and hybrid smart contracts. We'll go through and see what the problems are and how Chainlink solves them. So we've already had an introduction. You know who I am, Zach Ayesh. And I've been in the space, in the blockchain space for about 5 or 6 years now, since 2016. And, I fell in love with Bitcoin and Ethereum early in the day. I saw how these decentralized technologies could shape the world. I saw how much development was happening. And, when I discovered Chainlink, I obviously had it was an easy buy-in to see how important decentralized Oracle networks would be. Now in 2021, we have more than just Bitcoin and Ethereum. We have these newer awesome blockchains like Celo that take these properties and take them to the next level to give developers the best experience they can have. So one of the first topics we'll cover today is what is Chainlink, if you don't already know. So to make sure we're all on the same page here, I'm going to give a quick definition on blockchains. A blockchain is a network of computers all around the world that store data and transactions in a shared ledger that isn't controlled by anyone. Essentially, you can think of it as a database that has been replicated over many computers all over the world and secured by cryptography and game theory. Bitcoin is popularly known as the first blockchain. And Bitcoin is really great for things like value transfer, but there are other blockchains that can run application code on top. They can be thought of as application platforms. An example of this is Celo. Celo has a virtual machine on top of it, the EVM-based virtual machine that allows it to run programs. Another quick definition is contracts. A lot of us may already have a good understanding of what contracts are. We can define them as a binding agreement between two or more parties. A lot of us think of contracts as legal contracts, a document that's enforceable by law. And, contracts have been written on stone and paper and have gone through quite an evolution over the years. So, we've had the telegraph agreements, telex machine-based agreements, and today we're really in the digital agreement era, where almost all of our agreements are stored and based on the internet, and we're moving into the smart contract world. We'll get to smart contracts in a second. But in the digital agreement world, I want you to think of Netflix. Netflix is a service a lot of people use to stream videos. And they have a user agreement that underpins their technology that says, hey, we'll provide you 24/7 access to our streaming library for a certain price per month. So, as I was saying, digital agreements really have defined how we do agreements in the past decade. From bank agreements to that Netflix example to maybe your favorite crypto exchange. They all have digital agreements that underpin their technology. But you may notice one common aspect between all of these digital agreements. There's one party enforcing and executing these agreements, the party who created them, the enterprises. And because of this, the relationship between the users in these agreements are not what we think. For the users, these agreements can actually be high risk and low control, with some monopoly rents being extracted by institutions and platforms. If you've ever thought about taking one of these agreements and taking them to a court of law, you may have realized, it's too expensive to actually enforce these agreements from the user perspective. We call these types of agreements paper or brand-based agreements. You're entrusting these enterprises and industries to act in good faith and based on their reputation, which can work, but not all the time. So a specific type of digital agreement I want to go into is traditional financial digital agreements. So we'll call them CFI for Centralized Financial Digital Agreements. So an example of financial digital agreements are, if you've ever gone into your bank account and signed in and had a checking account, or maybe gone to your favorite crypto exchange or even equities exchange and exchange stocks, these activities are governed by CFI digital agreements. And centralized CFI products built on top of these agreements can work very well in predictable market conditions. But when conditions change and get a little bit more chaotic, this can change very quickly. An example I want to go into is Robinhood. If you're not familiar with the Robinhood platform, they're a trading platform for equities like stocks. And users read their digital agreement or believed the digital agreement stated that they could buy or sell stocks anytime the market was open and at their preferred conditions. So a bunch of users decided to exercise this digital agreement, or what they thought the digital agreement said, to buy GameStop stock all at the same time. But the reality was Robinhood's digital agreement was not what they expected, And at that moment where they wanted to buy GameStop stock the most, the service actually went down and stopped them from enforcing what they thought was the digital agreement. And so, we can't always expect CeFi to support the average user. Enter smart contracts. Smart contracts can be defined as a self-executing contract without the need for a third party, essentially code. If you think about it, Bitcoin can really be thought of as a basic form of a smart contract, where the code is there really only to transfer value. Ethereum came around and allowed any form of smart contract to be built on top of its EVM. And today, we have even more advanced blockchains like Celo that allow smart contracts or this code to be written on top of them. And today, smart contracts essentially refer to programs written on top of a blockchain like Celo. So why are smart contracts superior to digital agreements? Many blockchains like Celo have been live for years and without incident, and a well-designed smart contract cannot be changed after its deployment. You get that guaranteed execution. Traditional agreements are executed and enforced by that typically centralized party in the agreement, who may or may not execute the terms of the contract immediately when those terms are met. In smart contract world, none of the parties have control of the execution of the contract. The contract will execute immediately when the terms are met. Imagine insurance. In insurance, the contract typically isn't executed right after an incident happens. Let's say you have car insurance and you have a wreck. Rather, you have to start a lengthy and timely and costly review process. It could be months to years before your insurance contract is paid out. Transparency. Traditional agreements can be very hard to access and can easily hide details from users and other systems. This actually creates issues like the 2008 financial crisis, which was caused by very complex and opaque contracts in our financial system. And smart contracts are transparent by default. And again, the enforcement is unavoidably built in. Trust minimization. Again, no one party controls the execution of these agreements. They're built on top of blockchains like Celo, which have many nodes running on them. And no one party can control the outcome of that blockchain. So if Robinhood had been coded on top of Celo, for example, no one could stop that agreement from being enforced. And finally, efficiency. Due to all those things I described earlier, smart contracts can create more efficient and automated costs. I want you to think about all of the money these institutions spend on having giant legal teams and programmers to quadruple check their code to make sure that the insurance contracts or the digital agreements are coded up right. And this way, we're kind of automating all of this and this can save businesses millions of dollars in costs. So smart contracts are great. But in order to understand Chainlink, we need to understand a little problem a lot of smart contracts have. Natively, smart contracts actually can't connect to external data or any off-chain resources on their own. This is a big limiting factor for smart contract adoption because if we can't connect to outside resources, it really limits smart contracts to ownership and transfer of value. You may be asking yourself, why can't we just connect our blockchain to the outside world? Maybe to an API, if you're a programmer. Well, blockchains inherently are deterministic by nature. So all the nodes in the network have to receive the same values. So if you look at this diagram here, on the left, we have a blockchain running with several nodes that's just doing some basic math. All of the nodes come to agreement. Consensus can be reached between those nodes. On the right, we have a blockchain connected to outside data resources. And the node on the bottom left makes an API call to get maybe the price of an asset. And then 1 second later, the node at the top makes the same API call and gets a different price. Now the nodes cannot reach agreement because they requested it at different times, especially in the world of volatile crypto assets. This would break consensus and break the blockchain. So this is called the smart contract connectivity problem. Blockchains are just unable to connect to the outside world natively. They're stuck validating value transfer and ownership of tokens without some sort of other mechanism. We're going to need some kind of middleware that sits in between the blockchain and the outside world to solve this. So what's the solution? An oracle. That's what we call that middleware that sits in between the blockchain and the outside world and allows them to communicate so we can build these awesome dynamic applications that trigger based on real world events. And the oracle can work in both ways as well. Now, outside systems can trigger based on events that happen in the blockchain. The possibilities are endless now. But here's the thing. A naive way to solve this, to build an oracle, would be to build a centralized oracle. Maybe we have a single node that acts as an oracle, a single piece of software. Now that centralized oracle becomes a single point of failure for an entire smart contract. And if you're building a smart contract on Celo, you're putting it on this awesome blockchain that has decentralized nodes. You're trying to get all those awesome properties that smart contracts allow. And now you're relying on a single node. In that single node, they could be corrupted, they could be bribed, they could be hacked, or they could simply be malicious and act in their own self-interest. This could put user funds at risk. So to answer this, Chainlink allows you to create decentralized oracle networks. Chainlink is designed to be a modular, decentralized platform for creating oracle networks that connect our smart contracts to the off-chain world in a very secure way. If we look at this diagram, you can see Chainlink nodes all communicating with each other, grabbing the price of a certain asset. And these nodes are aggregating those prices themselves to get their own sources of truth, then communicating between each other and aggregating that answer into a single point of truth for that asset and posting them on chain on the right. So by combining on-chain code and off-chain systems with oracles, we can even take smart contracts to another level called hybrid smart contracts. These are smart contracts that can really redefine what we're doing in the industry. It's not just on-chain code. It's off-chain resources as well. And we're already seeing this take off and kind of redefine the industry. So let's dive into a very specific example, the Chainlink data feeds. Let's define DeFi, decentralized finance, first. DeFi is, as opposed to CeFi, which we discussed earlier, is basically taking all those CeFi digital agreements, putting them on chain and making them smart contracts. So you could have lending and borrowing and exchanges just like we have in CeFi, put them on chain, and now they are DeFi. So Chainlink's DeFi solution is what we call data feeds. So some of the best and highest quality node operators on the planet have combined their prowess to build what are called reference contracts. It's kind of like that image I showed you earlier of all those nodes coming to consensus to post on point, these data feeds can be thought of as decentralized on-chain reference points and sources of truth for various currency and other data pairs. So like the price of ETH and USD or Celo versus USD as an example. And so, on the left, we have, in this diagram, we have exchanges, we have market makers generating price points, and slightly to the right of those exchanges, we have data providers. These data providers aggregate various prices from exchanges, but they are centralized points of failure. The Chainlink nodes then each individually aggregate data from each of those data providers and the exchanges to come to their own price points. And again, between those Chainlink nodes, they aggregate all that data once more to post that data onto the reference contracts that now Celo developers can make use of in their smart contracts. We can see this process happening live on data.chain.link. So let's go ahead and go there. Okay, so here we're on data.chain.link. And as was alluded to earlier, right now we're showing on the Ethereum mainnet, but Celo mainnet is currently in progress and being worked on. So we will be able to see that in this list once that is ready. But let's just dive into BTC USD as an example here. Now we can see that process happening in real time live. This is just pulling data from the blockchains. So you can see all of the different node operators that we have posting on here. So they're all putting their reputation at stake to make sure this all works well. You can see the final trusted aggregated answer here in the top left, and each data point that each node provider has put in there. You can see they're all essentially the same, but slightly different. And this is why we want to aggregate that data and make it into a single data point. We can also see a couple of the users that are using this data feed on this network and some historical price data. So it's really cool to watch this happen in real time. We have the heartbeat right here that shows how often it'll update if the deviation threshold isn't met. The deviation threshold says, hey, if the price of this asset changes more than 0.5%, regardless of the heartbeat, let's have the Oracle network post an update. So those were the data feeds, and why are we stressing these decentralized Oracle networks? Well, as I said earlier, centralized oracles and insecurely built oracles are a huge attack vector for smart contracts. And we've already seen projects that have literally lost millions of dollars from themselves and their users, often due to centralized and insecure oracles. We definitely don't want that. We don't want anyone's funds to be stolen. So using the most secure Oracle solution is of paramount importance. And some of the biggest DeFi projects today are currently built and powered by Chainlink. Chainlink is supporting many of these projects, and there's billions and billions of dollars locked in DeFi, and we definitely don't want those funds to be hacked due to some malicious actor. So earlier in the before we started this presentation, we were talking a little bit about NFTs and randomness and all these other functions that Chainlink allows smart contract developers to access. So let's go ahead and dive a little bit into that and talk about the Chainlink VRF. So we talked about this a little bit in the context of NFTs, but the Chainlink VRF allows smart contract developers the ability to access provably random numbers in a very secure and decentralized way. As we said earlier, one of the most popular use cases for this is NFTs, whether they be gaming or art NFTs. You may want to give your users, if you have an NFT packet that's like a pack of cards that they have a 1 in 1,000 chance of getting that ultra super rare card, you can use the Chainlink VRF to give those users assurance that they actually have those chances at getting those rare cards. And it's not being manipulated by some centralized source. The VRF does this by some very advanced cryptography. You can look into this. There's articles on it online on blog.chain.link on how the VRF works. But essentially, it does this cryptographic magic and posts a proof along with every random number that's verified on chain. Another awesome product is Chainlink Keepers. So another interesting limitation of smart contracts is they can't actually execute their own code. They need an external actor to initiate that code. So maybe you have a smart contract that you want to run every hour or every day or every week, or based on some arbitrary external conditions. Chainlink Keepers allow smart contracts to automate themselves while, of course, retaining those awesome decentralized properties of blockchains. So what's an example? In DeFi, we have the concept of over-collateralized loans. Most loans in DeFi are over-collateralized, and what that means is that users have to deposit collateral, and they can borrow money against that collateral. They retain ownership of it, but it's locked into a smart contract. This collateral has to be worth more than the amount of money they take out as a loan. And if that collateral falls below a certain point, that loan needs to be liquidated, and someone needs to take ownership of that collateral in order for the DeFi app to continue to work properly. Well, traditionally, we've just kind of relied on external actors and hope that they will follow the game theory and liquidate those loans. But this has been shown in the past to not always be reliable. And Black Swan events like last year we had like Black Thursday, that many loans have gone unliquidated. So Chainlink Keepers can be used. You can contract Chainlink Keepers to come monitor that smart contract and only execute when loans become under collateralized, and have them be the liquidators that liquidate those assets, assuring you as a developer and your users that your DeFi app will continue to work as promised. Chainlink can also be used to access any arbitrary API that's out there, whether it's a web API, enterprise system, or a database, Internet of Things censored, or an API-enabled physical device such as a car. We've had projects that have even connected using this service to their Tesla, where they use Chainlink as a middleware and created a smart contract, put it on chain, and allowed logic that was automated based on data that was being reported from their Tesla. This is really great for, especially for MVPing a hackathon project, or maybe you're building a new project that doesn't already have a decentralized Oracle network, and just MVP, you don't want to go through all the effort of building your own decentralized Oracle network or contracting someone else to build that Oracle network. So you can use any API for that service. And nodes for the AnyAPI service can be listed on any marketplace, and one of the most popular is market.link. Market.link is a place where Chainlink node operators go. They can put their give visibility on their node, put the jobs that they're going to do, jobs of the type of work that they can provide smart contracts, and they can share any special what we call adapters, which determine the logic of those nodes. And feeds and data providers can also list themselves on market.link. Highly suggest checking it out. So where can you learn a little bit more about Chainlink? Our docs are an amazing resource. I push as many people as I can to our docs. We have tutorials on the docs from beginning, intermediate to advanced, that if you don't know anything about smart contract development, will take you from zero to hero in your journey. Each of our products have in-depth guides and one-click deployments, which we're going to see in a bit. So it's very easy, and they're open source. So if you're going through the docs and you're like, man, there's a typo, or something is, I think something could be done better, go to our GitHub, and there's a button on the top of the docs that you can click that'll take you to the docs GitHub and make a pull request or open an issue, and the team will take a look at it. The Chainlink blog is also a great place to go if you want more in-depth kind of technical tutorials or announcements or explainers for subjects that may be outside of Chainlink as well. One of my my favorite blogs, and one of the most popular, is the 77 use cases enabled by Chainlink. So if you've watched this presentation and you're thinking, man, hybrid smart contracts are awesome. I know I can build some really cool stuff because the space is ripe for innovation, but I don't know what I could build or where hybrid smart contracts can be used. Check out 77 use cases enabled by Chainlink, and it'll give you some good jumping points on how to think about how to design your future smart contract. And if you prefer watching videos, we have a YouTube channel with all kinds of live demos and tutorials and walkthroughs that you can go through at your own pace and watch in real time as the demo goes on. And finally, we have our starter kits in Truffle, Hard Hat, and Brownie. These are if you already have a little bit of development experience and you want to develop locally and make tests and have that all automated. The starter kits are already preloaded with some basic tests, all the Chainlink smart contract examples that you could need, and make a really great developer experience for developing locally. And of course, these will totally be compatible with Celo. It's an EVM-based it's an EVM-based blockchain. So you just have to change a couple of config variables, and bam, they're connected. All right, so let's jump into a quick demo. I'm going to go over some of the services that I talked about. So I'm going to specifically use Chainlink data feeds and AnyAPI. I'll also try to see if we have some time and get that VRF, since we discussed that in our kind of introduction. So what do I have? I have MetaMask installed in my browser. I have testnet ETH. So for now, we'll be doing this on Kovan testnet, and testnet link in my wallet as well. And we're going to start at the docs. So I mentioned that I always recommend people go to the docs, and I really do. I use them myself. And so here in the nav bar, you'll see an introduction. You'll see, if we scroll down, you can see all of the services that we offer. And, we're actually just going to go to introduction. We'll go to tutorials, the basics. And at the beginning here, it actually walks through, a lot of things we talked about today. What is a smart contract? What language is a smart contract written in? So I highly recommend, if anything I said today was a little confusing, go through, try going through this demo, and it should give you a good idea of what all of this means. If we continue to scroll down, you'll see an example smart contract that uses the Chainlink data feeds. We'll actually keep scrolling down, and you'll see a button here, deploy this contract with Remix. So we're actually going to deploy this using the Remix IDE, which is a web-based developer environment. Awesome. So we have Remix loaded in here, and it's automatically pulled in that very same code we were looking at in the beginner's tutorial. So if we just quickly browse through and try to understand what this code is doing, we have this import statement, import Chainlink and eventually aggregator v3 interface.sol. This is really the only interface you need to make your contract compatible with Chainlink data feeds. We have contract price consumer v3, the name of our contract. And all we have to do is in our constructor, well, in our state, we're going to say, hey, this is the price feed. In our constructor, we're going to initialize that price feed to a certain address. In this case, it's going to be the ETH USD price feed on Kovan. And finally, we just have a single function, get latest price. And we're going to access that price feed. And let me zoom in a little bit, so it's a little bit more legible. But we're going to look at that price feed and use the latest round data function off of that price feed. That'll pull in a couple of values, but the one that we're going to want is price. That's the only thing in this demo that we're concerned about. So we'll come over to our Solidity compiler, and I have it on auto compile. So everything is good there. It's giving us a couple of informational warnings, but nothing that's stopping compilation. So we're all good there. And if you don't have it on auto compile, hit the compile button. We'll then come to deploy and run transactions. And we'll go ahead and shift this to injected Web3. This is where we will have our Remix read from our MetaMask. It'll connect to MetaMask and see what network we're injected in or we're connected to. So in this case, it's connected to Kovan. And again, since Celo is EVM based, we could easily just change some configs in MetaMask and have it deploy there. So we're going to go ahead and switch our contracts to price consumer v3. We're going to make sure it's pointing there. And we're going to click deploy. My MetaMask is going to come up and say, hey, it's going to cost some gas. It's all testnet. So we'll go ahead and hit confirm. And we'll wait for Kovan network to mine our transaction. It's gone through, and at the bottom, you'll see our contract. We'll click get latest price, and fingers crossed, we should show the price of ETH USD. Bam, we got it. Solidity doesn't support floating point numbers, so it's going to show all as an integer, a full integer. But there's another function to get decimals. You can see that in our documentation. And so that is how easy it is to utilize data feeds in your contract. It's as simple as an import statement and running a single method. Now, if you're designing your smart contract and you wanted to activate based on the price of an asset, you just have to make a method and point it to this get latest price method. Awesome. So now let's move on, and we will go back to our docs. And let's go ahead and do AnyAPI. We'll click make a GET request on here. So that's what we're going to do today. We're gonna use AnyAPI to connect to an example API and make a GET request to that API and return some values and use it in our smart contract. Again, this is really useful for making a hackathon project or demoing a new product you're building. So we'll go to the docs. And again, if we scroll down here, we see that we have our Solidity code, an example contract, and a convenient button that deploys it on Remix. Okay, so we're back in Remix, and we see now we have a different import. Import Chainlink contracts, and all the way down to Chainlink client.sol. This is the import we need to access the AnyAPI solution. We have our state variables that define some variables we're going to need to start our AnyAPI request, and one for the data that we're actually going to retrieve. Our constructor sets those state variables, and we're going to need to set a specific oracle we want to send the request to. We're going to need to set the job ID, which tells, hey, this oracle may do a couple of different jobs. This is the specific job we want to use. These can all be found on market.link or in the Chainlink docs. And this time, we're going to have a fee. Since we're making a request to a Chainlink node, we need to pay that node in link tokens, just like you would in a blockchain to pay for a transaction. to pay that node operator for their service. Finally, we're going to have a function request volume data. So this job, we're going to make a request, and we're going to make it a GET request to cryptocompare.com to get the volume of ETH in USD. So we're going to create this object in memory in our contract called a request. We're going to say this is the path. When we get that request, when the Chainlink node makes that request and gets a response back from the API, it's going to have this complicated JSON. We're going to say this is the path you need to follow down in that JSON to get an end value. And then we're going to send off that request. So since this is kind of an async workflow, we need to send that request to the Chainlink node, and then that Chainlink node is going to respond to our smart contract. And it's going to call this method fulfill. We'll get our volume data out and post it through this function, and we'll save that volume in our volume state variable. So let's go ahead and we'll make sure it's compiled again. No red notifications. We're all good. We're getting the green check mark there. Switch to injected Web3. Switch our contract. Make sure we're pointing to the right one. We want API consumer. Click deploy. My MetaMask is coming up with a notification. Confirm. And we have our contract. Now, we're going to want to copy this value here. Remember, we need to pay the Chainlink node in link tokens. So to use the service, before we can send our request out, and we call that function, we're going to want to load our function, our contract with some Chainlink tokens. So I'm actually going to go into my MetaMask. I'm going to click send. I'm going to paste that address of our contract in, and I'm going to put in link. I'm just going to send it 0.3 link. MetaMask is going to do its funky stuff and estimate it as 0.2999. No problem. And we'll hit next. Confirm. And we'll adjust the screen a little bit more so we can fit this all in. Once this transaction is included, and it should be, yep, so our link went, now we can run that function request volume. Go ahead and click that. Confirm. And if you hadn't loaded the contract with link, it would have thrown an error. It would have said gas estimation error. You can't go through. So if you see gas estimation error, you know, hey, I forgot to load my contract with link tokens. No problem. So our request volume transaction went through, but if I click volume, it's actually just going to show 0 right now, which is what it was initialized at. So why isn't anything showing there? Well, remember, we made the request to the Chainlink node, but now we have to wait for that Chainlink node to get that data and post it on chain, and the blockchain has to confirm that transaction. So this could take a couple of seconds, maybe a minute or two tops. But it's already posted through, and we have the volume. So if we go back to the docs, one of the last services is using randomness. Just like using AnyAPI, we can go to get a random number. We have our deploy this contract with Remix, which has an example VRF contract. If we go there, we pull up our Remix editor. And this time we have a different import, VRF consumer base. Just like the jobs, we're going to need to set a couple of variables depending on the chain it's on. In this case, the VRF coordinator address and the link token address on that chain. And this works just like any API, where we have a function that sends a request and a function that receives an answer from the service. So in this case, instead of a Chainlink node running a job, we have the Chainlink VRF returning randomness. So get randomness sends a request to the Chainlink VRF, fulfill randomness will take that randomness, and we can then use it in our smart contract. Now, just like any API, we have a fee. We need to pay that contract and that VRF and link tokens. For the sake of time, and so we still have some time to answer some questions at the end. I'm not going to walk through this. The workflow is exactly like the workflow for any API. And if you get stuck, again, go back to the Chainlink docs, and I guarantee you these docs will walk you through exactly everything you need to know to make sure you're successful in getting that random number, so you can make those awesome dynamic NFTs that have randomly generated attributes when they start. Or make sure that your trading card pack has provable randomness for your users trying to get that ultra rare card.
Wow, Zach, you went through a lot there.
Yeah, it was. There's a lot to go over.
I'm impressed. So one thing that I want to mention is when you're doing your initial demonstration, you basically had 12 lines of code there to interface and retrieve oracleized data.
Yep, it's that simple. That's all you really need.
That's amazing. And this is a testament to the power of like MVP. So if you're a hackathon participant and you're like wondering, how do I get started? Well, one, you can always just start with mock data. You don't actually have to use the live service initially for an MVP. As you're developing it, you can utilize mock data to develop your use case, provide an example, and then you can take it to the next level by incorporating with 12 lines of code to obtain real metrics oracleized to your contract. So Zach, correct me if I'm wrong, but it seems like the general overview, especially for folks like in hackathon interested in utilizing Chainlink oracleized data, they want to test. The process is pretty much you develop your smart contract, you set up your interface, right? Then you need to deploy and fund it with a Chainlink token, and now it's ready to go. Am I missing anything here?
That's basically the workflow. Yeah, it's like you said, that's great. I think that's a great help to developers to mock that data. Don't let the fact that Chainlink isn't quite live yet on Celo deter you from just mocking the service. The service will be available and is being worked towards in the future. So mock it. And if you look in those starter kits I discussed earlier, and I can just quickly go to the GitHub. We'll go to GitHub and we'll go to Chainlink. You'll see these starter kits pinned on the top of the smart contract organizational GitHub repo, and they have these mocks built in. So like, let's say you're a JavaScript developer, you go to the Hard Hat starter kit, and we actually have contracts, test, and mocks that you can utilize in your smart contracts to help you mock the Chainlink services.
Zach, that's a great resource. Can you copy that and send it in the chat? I'm sure participants would love to access that link. Mock data is super important, fast way to prototype with your project as you're developing it. And it inspires other people too in regards to inspiration for the project you're working on. As a hackathon participant, maybe you're not actively participating in a hackathon. I'm going to tell you right now, you should be joining the hackathon because good things are coming. And builders in the space are definitely benefiting. Like there's a lot of untapped opportunities right now on blockchain globally. I think the space is definitely geared towards the builders in the community. So all attention, hands on deck. Let's start building. And Chainlink, what a solid way to interface and generate randomized data. Because if you're new to smart contract development, there's no built-in way to randomize data. And I think people miss this point. It's like, if you want to randomize data and you're trying to come up with some type of method to randomize data, and you're not using services like Oracle's, you might be incorporating potential security risk, right? Because there's just no methods built in to Solidity to do that.
Exactly. And, like I showed earlier, people have been attacked for doing that, if they try to spin up their own Oracle solution. So there's a saying in computer science, never roll your own crypto, never try to reinvent the wheel and create new cryptography, because that will introduce security flaws. Same with oracles. Don't try to roll your own oracles. Take advantage of the shared security of having a complete solution available to you.
Yeah, and to touch base on that, Zach, you mentioned the fact that Oracle can be centralized and decentralized. And with Chainlink, it's decentralized. It's complementary in regards to the development of a decentralized platform. Nobody can, it's a trustless service provider, essentially, right?
Exactly. And yeah, the code is completely open source. I'm already on the GitHub. So let's just scroll over here and we can actually take a look at it. We click on Smart Contract Kit and we go to Chainlink right here. This is the code. This is the magic sauce that makes Chainlink. It's all done open source. It's transparent. And anyone can, you can contribute to this code. You can take it, you can run it yourself. You could use this code and you could build up your own decentralized Oracle network. It can be, there's a lot of challenges involved, but anyone can do it. It's there. And I suggest checking it out if you're interested.
Zach, perfect. I wanted to take a moment to ask the audience, is there any questions that you would like Zach to address today before we conclude our streamcast?
I'll just leave it on here. So you see we have our documentation in Discord if people need those links.
In case they want to connect later, right? Always reach out. That's why you're here, Zach, right? To connect the community.
Exactly. That's the thing. Yeah, we're very active on Discord, also Stack Overflow. So yeah, feel free to reach out anytime if you have any questions or need help developing. I want to make sure all the developers developing on Celo are as successful as they can be in building the future.
Well said, Zach. Thank you so much. I did notice that we had a pending question about template frameworks, dynamic NFTs that we were talking about. I shared a lot of resources. As you were talking, Zach, I took down some notes. I pasted those right in the chat. So you have those resources. Those resources address the template framework for dynamic NFTs. There's actually a tutorial right on the docs at Chainlink. And I advise always go to the docs. If you're ever wondering about what to do in the space with Chainlink, with Celo, go to the docs. Just search the docs for a platform, type in your question in the search, and you typically will find the information you need to get started as quickly as possible. If you have a bottleneck and you're like, I'm stuck in the docs, they're not making sense, reach out on Discord. You got Zach shared his Discord link right here. There's a community there ready to facilitate. If you have a question that hasn't been solved, somebody else most likely asked the same question. Resources should be there for you. Same thing on Celo. We have our Discord. Feel free to join the Discord if you're not in the community. It's a fantastic way to participate in the sandbox so we can build together.
Well said. I couldn't have said it any better myself.
Oh, Zach, you're too good. Come on. All right. Well, thank you so much for your time today. This is super exciting. I'm looking forward to the future of Chainlink Celo coming soon. Fantastic things to come. Thanks again for your time today, Zach, and thanks to the community for watching.
Yes. Thanks, everyone. It was great. See you next time.